every left parenthesis has to match with the corresponding right parenthesis, and any right parenthesis must have a corresponding left parenthesis. So every left and right parenthesis have to be matched. Also, the left parenthesis must come before the corresponding right parenthesis. So left parenthesis have to be present before we use a right parenthesis. And regarding the third character, which is star, so for the star, uh, we are told that we can use it as either a right parenthesis or a left parenthesis, or we can use it as an empty string. So we can ignore it by using by treating it as an empty string. Also, if we are given an input as empty string, then it should be returned. Empty strings are considered valid. So if you consider these examples that they have given, uh, there is a left parenthesis and a right parenthesis. So this is a valid string. Now, in this case, if we treat star as a empty string, then this becomes a valid string. And in this case, if we treat the star as a left parenthesis, then this becomes a valid string. It will have a balanced parenthesis. So this is the function that we have to write. So let me first try and give you some intuitions. And so what we can do is we can iterate through the string, and we can keep track of the count of left parenthesis, and whenever we find a left parenthesis, we'll just increase the count by 1, and whenever we find a right parenthesis, we can decrease the count by 1, and whenever we find a star, there are three possible values that this star can hold. So it can be a left parenthesis or a right parenthesis or an empty string. So we can loop over these three characters and basically do a recursion, assuming each of the possible values for left parenthesis, right parenthesis, and an empty string. So we can first increment our count, we can decrement our count, and we can pass in the same count as it is, and check if the result string, if any of the result string comes out as valid string, then it will be the overall string can be treated as a valid string. So what we'll be doing is in that case, we'll be trying to generate all possible strings that can be generated by manipulating this star, by providing all possible values for star, and generating all possible strings. So in this case, we'll end up with uh, three three possible strings, uh, two left parentheses and the right parenthesis, one left parenthesis, two right parentheses, and one left and one right. So we can in that case only the last string becomes the valid string. So I tried to code this up, and my solution was not getting accepted. It was coming as time limit exceeded. So I realized that what they really want is not to try for all possible values. What they really want is to just probably keep track of the stars that we encounter. So I tried to come up with a different algorithm, and in this case, what I came up with is using a stack. So 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 what we'll be doing is let me give you some idea about how we'll be using this stack. So if you take a look at this example, now if you consider this as the string, so here you can observe that star is present before left parenthesis. So this star cannot be used to balance this left parenthesis, and if this were the input string, then this would be an invalid string. Whereas, sorry, whereas if you consider this as the string, then you can see that we can balance off this parenthesis by converting this star to a right parenthesis. So, so the position of the star matters when it comes to left parenthesis. The same thing is not true when it comes to right parenthesis. So whatever star is present before right parenthesis can be used to balance it off, but not all stars that are uh, present before present before the left parenthesis can be used. So what we'll be doing is we'll be keeping a stack, and the manner in which this stack will be filled is whenever we encounter a left parenthesis, we'll be pushing every star and every unbalanced string into the stack. So what we'll be doing is all the stars that we encountered before encountering this left parenthesis, we'll push it onto the stack. And as long as we do not encounter a left parenthesis or a right parenthesis, we'll just keep track of the stars that we have encountered in star count. So what we'll be doing is we'll be first uh, incrementing this star count as long as we do not encounter any of the parentheses. And as soon as we encounter the left parenthesis, we'll push this many stars onto the stack, and then push a left parenthesis on top of the stack. So the idea behind doing this is whenever we come across a right parenthesis, we do not want it to be first balanced by the star. We want it to be first balanced by whatever left parenthesis that we have already encountered. And that is what we will be keeping track by using the stack. And whenever we come across a right parenthesis, we'll first try to satisfy the right parenthesis with the left one that is already present in the stack. And if there are insufficient left parentheses, then we'll be prioritizing this star count. We'll start decreasing this star count, and if we run out of this star count, we'll use the stack as well. So that is the idea. It should become more clear when I start implementing the solution. So so let's get started. What yeah So what we'll be doing is we'll be creating a stack of characters. This will be char stack. This will store all our stars and left parentheses. We'll never be pushing a right parenthesis onto the stack. It will always be stars and left parentheses. And also, there will never be stars at the top of the stack. It will always be a left parenthesis, and whatever stars that we have found will always be present below the stack. And if we end up with popping off this left parenthesis, what we'll be doing is we'll remove all the stars, and we'll add them to the star count, so that we always end up in the stack with either the stack will be empty, or the first character that we find at the top of the stack will be a left parenthesis. So uh, so with that information, let me start off. So we are creating a star count as the integer, which will keep track of whatever stars that we have found, and then I'll iterate through the string. And let's extract the character uh, that we found at index I. And if the character that we found is a star, then we'll just increment the star count. We won't do anything with the stack, but as soon as we encounter a left parenthesis, what I'll do is push all the stars that we have found to stack. So this is the stack, and how many stars, whatever star count is found, and we'll just reset the star count to 0, and then we'll push our left parenthesis, sorry, so push our left parenthesis to cat stack. We'll push our left parenthesis to the character stack. Okay, and when we encounter right parenthesis, what we'll do is there will be two cases in this case. Either as I discussed in this, either the stack will be empty, or either the stack will be empty, or the character present at the top of the stack will be a left parenthesis. So if the stack that we encounter if the character stack that we encounter is empty, that means we do not have any of the left parentheses, and we only have probably only have stars. So what? How many stars will be present? Whatever star count is holds the value, those many stars will be present. So if our star count has already become 0, then there are no more stars left, but we have an excess of right parentheses. So in this case, this will become an invalid string. But if we have enough stars, then we can assume that star count can be decreased, uh, and this right parenthesis can be balanced. The other condition is we encounter the stack is not empty, and we came across our right left parenthesis. So that is present at the top of the stack. So let's say if we came across right parenthesis, left parenthesis, this is confusing. Uh, so let's say if I came across a left parenthesis, then I can just pop it and say that the right parenthesis has been balanced by the left parenthesis. But now we have to check if there are stars present at below this, then those needs to be converted back to those the number of stars that we have need to be put back into the star count. So uh, so what we'll do is we'll say star count, and just remove stars from top of this stack. So this will remove the all the star characters that are present at the top, and it will not it will stop whenever it encounters either the stack becomes empty or it encounters a left parenthesis again. So that is what we'll be doing. Now, when we come out of this iteration, uh, there should ideally be no right parenthesis left, and will either have an empty stack, in which case this will be a valid string. But if we do not have an empty stack, what will be left with is either a left parenthesis or a bunch of stars. Now, if we are left only with stars, then there is no issue as such, because we can treat them as an empty string. But if we are left with a left parenthesis, then those left parentheses present at the top of the stack will have to balance with whatever value is present in the star count. And if we have more number of left parentheses in the stack than what we have the star count, then those cannot be balanced. So what we'll be doing is while the stack is not empty, we'll just check uh, if the character that we found at the top of the stack, if let me extract the character first. So if the character that I found at the top of the stack is a left parenthesis, then what I should be doing is checking whether the star count uh, is uh, is greater than 0. So if I have any of the stars left, then I can just decrement the star count and balance off my left parenthesis with the stars. Otherwise, if I do not have any of the stars left, then I have excess of left parenthesis, and this becomes an invalid string. So I'll just return false. The other possible character that can be present at the top of the on the stack will be a star. So as long as we keep getting stars, I'll just keep incrementing my star count, and at the end, if we came out of the loop, that simply means that all the left parentheses were balanced off, and whatever star count value is present, that will be the excess of stars that we have, and we can treat them as empty strings, and there is no left parenthesis left. So all the right parentheses are balanced off during the iteration part, and all the left parentheses that are still left out, which are unbalanced, can be balanced off in this final while loop. And so we can just return true in this case. So let's run this and check if this works. Oh, I have to implement these two methods, push stars to stack and remove stars from top. So let me implement them. Push stars to stack, and this will contain a stack of characters. Let's just call it a stack, and it will tell me a count. And what I'll do is I'll just push those many stars onto the stack dot push stars. Okay, and the other method that I have to implement is this actually returns an integer and takes a stack as the input. What we'll do is while the stack is not empty, and let's just handle the if else. So, and we'll just check if the stack the character at the top is a star, then we'll just have to maintain a count of the stars that we came across. So I'll just increment the count and pop off that star, else I'll just have to break off the loop, and I'll return whatever count I found. So yeah, let's run this and check. Yeah, so it worked for this balanced input. Let's try for some other strings like the one that we found earlier. So let's try for invalid string like this. So this should return false, and it matches. And let's say if the star is present after the left bracket, then this also works. So let's submit this and check. We are iterating through this string only once, but because of this push star to stack and remove stars from top, we'll end up doing multiple iterations back and forth. So our solution got accepted. Yeah, it is almost good, but yeah, there are other better solutions. So yeah, I'm sure there must be some dynamic programming based approach to solving this, but I'll leave it up to you to figure it out. And if you do come across, then do let me know in the comments. And if you like this video, then give it a thumbs up, and yeah, please subscribe to the channel so that and click on that bell icon if you want to be notified about the 17 problem. So thank you.